In the first part of lesson one, we're going to do a linear optimization problem, sometimes called linear programming. A farmer is going to divide her 40-acre farm between two crops. The seed for crop A costs $25 per acre. The seed for crop B costs $50 per acre. The farmer can spend at most $1,250 on seed. If crop B brings in a profit of $60 per acre, and crop A brings in a profit of $140 per acre, how many acres of each crop should the farmer plant to maximize her profit? X is going to be the number of crop A acres, and Y is going to be the number of crop B acres. So the first constraint here is X greater than or equal to 0. X is the quantity of acres of crop A. You can't have negative fields of crop A. You can plant 0 acres. You can't plant -1 acres. So you can plant 0 acres, 1 acre, all the way up to 40 acres. The next one, Y greater or equal to 0, is the number of acres that the farmer plants under crop B. And again, it can't be negative. It has to be 0, 1, 2, all the way up to 40. So these are like reality constraints. Time doesn't flow backwards, time flows forward. Quantities can't be negative. Now, in the graph down here, this constraint is this green line here. This pink constraint is modeled right here. Now, X plus Y, X is the quantity or number of acres under crop A. Y is the number of acres under crop B. And together, they can't exceed 40 because she has a 40-acre farm. She can't plant 41 acres. And this constraint is modeled by this blue line. Now notice if X is 0, then this says Y can be as much as 40. So this right here is X equals 0. Y can be anything between 0 and 40. The same thing goes for X. If the farmer, for whatever reason, chooses 0 acres of crop B, then the farmer can literally plant 0 to 40 acres of crop A. So the blue constraint passes through that point. Now the last constraint, 25X plus 50Y, this is the cost constraint. If the farmer decides to do 1 acre of crop A and 1 acre of crop B, then that will cost her $25 for crop A and $50 for crop B. 25 plus 50 is 75. 75 is less than her budget of $1,250. If she decides to plant 2 acres of both, well, this would be 50 and this would be 100. 100 plus 50 is less than or equal to 1250. I have Desmos opened over here. What I'm going to do, zoom in a little bit. I'm going to type 25X plus 50Y, and then less than or equal to. To get the less than or equal to, you type the less than symbol, and then you type equal sign, and then 1,250. And then we can see what that looks like. Okay, so 25X plus 50Y less than or equal to 1250 looks like this. A line that passes through the Y-intercept and the X-intercept. any pair of numbers, X and Y, that is on this line or in this shaded red area makes this true. A point up here, for example, makes this statement untrue. So these are points that make this statement true, and these are points that make this statement untrue. Now, the cool thing about decimals, it gives you the intercepts, 0 and 25, and 50 and 0. Okay, so what is, if X is 0 and Y is 25, what does this equal? Let's try it out. 25 times 0 plus 50 times 25. So X here is 0. Y is 25. When I multiply that together, I get 0. When I multiply these two together, I get 1,250. So 0 and 25, that point makes this statement up here true. At this point here, with X equals 0 and Y equal 25, we're on this red line. And when we're on this red line, that means this is true. Now, what about this point over here? This is 50 and 0. So X is 50 and Y is 0. So we're going to multiply the $25 per acre times 50. Then we're going to add it to the $50 per acre by 0. And we get 1,250. So this point here, X equal 50 and Y equals 0. That point is on this red line as well. If I type 25 times 0 plus 50 times 0, I get 0. Well, 0 is less than or equal to 1,250. So this point here satisfies that inequality. Another thing we can do, I can copy this. I can find the y-intercepts of that line by changing the less than or equal to equal. And then I can solve this for X. To find the x-intercept, I'm going to make Y 0. So this right here is 0. And then I can divide both sides by 25. 25 divided by 25 is 1. So when Y is 0, X equals 50. This red line passes through the point X equal 50 and Y equals 0. Now let's do the same thing for the y-intercept. I'll change the less than or equal to symbol to equal. We're going to find the y-intercept, which means we're going to have to multiply this 25 by 0. We're going to make X equals 0. This here is 0, so we're going to just delete it. And then we're going to divide both sides by 50 to solve for Y. 50 divided by 50 is 1. So 1 times Y is Y. So when X equals 0, what does Y equal to? Y is equal to 25. And that's this point right here. When X equals 0, Y equals 25. So that's how we got these lines here. The green, the blue, the red, and the pink. This black line, we're going to talk about this later. That's the profit function. Now, I'm going to show you how to come up with the feasibility region. The feasibility region is where all 4 of these constraints are simultaneously satisfied. So what I'm going to do is I'm going to type X greater than or equal to 0, Y greater than or equal to 0, X plus Y less than or equal to 40. And then I have this one up here, right? What I'll do is I'll move this one down. I'm going to change this one to green. I'm going to change this one to pink, but there's no pink. Change this one to blue. And I'll keep that one to red. When it's typed into Desmos like this, what's going on here is you're saying this is true, or this is true, or this is true, or that is true. We want and. So in order to do that, what I'm going to do is I'm going to press Shift to get my squiggly bracket. I'm going to copy and cut that and put it here. Then I'm going to do the same thing for y greater than or equal to 0. And then I'm going to do the same thing for x plus y less than or equal to 40. When I zoom that up, you can see the feasibility region. This right here is point B. This here is point A. This is point D. And that's point C. Now, there's another trick you can do. You can do this. Change this to equal to. Change this to equal to. Then you have x equal to 0 and y equal to 0. I'll change the colors of these lines. This is the red line. X plus y equal 40 is the blue line. X equals 0 is the green line. And then y equals 0 is the pink line. I'll use purple instead of pink. Now you have the feasibility region and you have the vertices. So this is A, D, C, and B. So vertex A is 0, 0. And you want to type it into MyOpenMath as 0, 0 with parentheses. Vertex B is right there. That is 0, 25 inside parentheses. Vertex C is 30, 10 inside parentheses. X being 30, Y being 10. And then vertex D inside parentheses 40, 0. 40, 0. And then I'll press enter to make sure that I got it right. Report the absolute values of the following slopes. Now, that's y. This green line is y. So in order to calculate the slope, I have to do this. I'm going to call it P for profit equal 140x plus 60y. To get the slope with this being the y-axis, I'm going to solve this for y. To solve it for y, I got to subtract this from both sides. 140x minus 140x, well, that's 0. If I do it to the right side, I got to do it to the left side. And then I have to divide both sides by 60, right? So I'm going to divide that by 60. I'm going to divide this left-hand side by 60. That number 8 line is equal to the number 9 line. I can do this individually, right? Using the distributive property. These two are the same. And then I can recognize that 60 divided by 60 is 1. 1 times y is y. If the profit happens to be 600, then 600 divided by 60 is what? 10. And then this would be the slope, 140 divided by 60. So 140 divided by 60 is the slope. So the slope of the profit function is 2.333. What about the red constraint? I'm going to do the same thing that I did here for the red constraint. The red constraint is right here. I'm going to solve that for y. So I'm going to subtract 25x from both sides. When I do it to the left side, I got 25x minus 25x, which is 0. If I do it to the left side, I got to do it to the right side. And then I divide both sides by 50. If I do it to the left, I got to do it to the right. $50 divided by 50 is 1, and 1 times y is y. This is equivalent to that. 1250 divided by 50, that's just 25, right? This is just 25. The slope, this should be red right here, right? These all should be red. This is the red line. The slope of the red line is 25 divided by 50, which is 0.5, right? 0.5. What about the blue constraint? Well, the blue constraint, it's really easy to figure that slope out. So if we go from this point down to this point, we drop 40. And then when we go from this point A to point D, we increase by 40. So the change in y is minus 40. And the change in x is 40. So 40 divided by 40 is 1. It's actually a negative 1, but we want the absolute values, right? These are all negative. And 40 divided by 40 is 1. Now, why do I bring that up? This profit function is steeper than the blue constraint and the red constraint. So the way linear programming works, it looks at the slopes. Slope is really important in the linear programming. It basically compares the slopes. When you compare the slopes, if this slope is the steepest, then this will be the optimal solution. If this slope is between these two, C will be the optimal solution. If this slope is less than both of these slopes, B will be the optimal solution, right? So let me show you how this works. With the last year's profit at $8,400, guess this year's optimizing profit level. Well, I'll just say it's $7,400 less. If I press enter here, watch what happens to the black curve. It moved in, didn't it? See that? It moved in. Now, there's no way we can be on points out here. Currently, the profit is set at 7,400, right? And I got it marked wrong. And that profit equals 140 plus 60y. Change it to a black color. The profit function's out here. No point on this curve is feasible. These points have to be on this blue line or this red line or in this red area for it to be feasible. This is not possible. Why? Because at this point here, she's planting more than 50 acres. So let's try 6,400. 6,400 is getting close, right? 6,400 is getting really close. So I'll change this to 6,400. We still got it marked wrong. Let's change it to 5,400. Now, 5,400 puts this black line, a portion of this black line is inside the feasibility region. So if I change this to 5,400 and I zoom in on the spot here, this point is now feasible. This point right here is the intersection of the blue and the black is now feasible, right? Any point on the black line between this point here and that point there is feasible. Correct? So all these points are feasible. So profits could actually be higher. And I'll demonstrate why. So let's try 5,600. We'll zoom in. It looks like this black line is just touching point D when the profit is 5,600. Can we have a slightly higher profit? What happens if I make this 5,610? Now notice what happens. This 1 point became 2 points, right? So now we're outside of the feasibility region. So it looks like 5,600 maximizes our profit. Now, one way to double check that is at point D, what is my profit? Well, my profit function is 140 x plus 60y. At point D, x is 40 and y is 0. Well, that's 5,600, right? So guessing 5,600 got us the correct answer. So the way the linear programming works is for these non-negativity constraints, the ridiculous constraints, as I like to call them, ignoring the non-negativity constraints, we have two inequalities in our feasibility region, the blue and the red. Linear programming calculates the slopes. It compares the profit function slope to these. And it starts on the right. And it says, if this is greater than both of these, then point D is our optimal solution. Knowing that, it then just plugs point D into the profit function to get the maximized value of profit. So how many acres of each crop should the farmer plant to minimize her profit? Well, at point D, she's going to plant 40 acres of crop A, and she's going to plant 0 acres of crop B, and then our profit is going to be 5,600. Now, I'll redo this problem with a different profit function. I'm going to reset this. Welcome back. Resetting the problem changes the slope of y to 210. Why? Because now crop B brings in a profit of $210 per acre. Crop A brings in a profit of 140. So that changes my profit function, right? And notice where the profit function is. It looks like its slope is between the slope of the blue constraint and the slope of the red constraint. So let's calculate the slope of this real quick. So we got, I don't know, the current profit is 94.50, 94.50 equal to 140x plus 210y. Solving this for y involves subtracting 140x from both sides. So 140x minus 140x is 0. If I do it to the right, I got to do it to the left. And then I want to divide both sides by 210. 210 divided by 210, that's 1. So the coefficient of y here becomes 1. I'm going to divide it by 210, and I'm going to divide 9,450 by 210. The slope of this line is 0.6666, yada, 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 yeah, 7, right? So now with the red constraint slope being 0.5 and the blue constraint being 1, notice the slope is in between the red constraint and the blue constraint. So the way the linear programming model works is it says if this is bigger than that and that, then our optimal solution is over here because the black line will be really steep, right? And then it says if that's not true, then do this comparison. If this is between that and that, then the next vertex, which is C, will be the optimal solution, right? So if I lower my profit level here to 8,500, notice that my profit function is coming down. We'll back it down to 6,400. 6,400 is getting close. So let's try 6,250, 6,350. 6,300. Looks like 6,300. 3010 is our optimal solution, right? That's vertex C. So it looks like 6,300 here. It is 6,300. Now let's just verify. The profit function slope is between the red and blue constraint. That means point C is the optimal solution. So when X is 30, Y is 10, we should be at maximum profits, right? So let's do this. X is 30. Y is 10. And when we do the arithmetic, we get 6,300. So the optimal amount of acres, X is going to be 30, and we go up from 30. Point C is at a height of 10. So she's going to plant 30 acres of crop A and 10 acres of crop B, and her profits will be maximized at $6,300. Now I'm going to reset it. I'll show you the third scenario. Okay, welcome back. We have pretty much the same graph as before, except the red constraint has been changed. X is now being multiplied by 50 and Y is being multiplied by 25. So if I were to solve this for Y, I divide everything by 25 and the slope would end up being 50 divided by 25. So here the slope of the red constraint is 2. The profit function has coefficients of 60 and 90. So the profit function, if I solve this for Y, I got to divide both of these by 90. So 60 divided by 90, which is 0.6667. Press enter. Okay, so now notice what happens to the profit function. This line is flatter than the red line and the blue line. Its slope is less than both slopes. When this slope is bigger than both those slopes, the optimal solution is going to be point D because the profit function is going to be really steep, right? So the linear programming model looks at this and compares it these two. If this slope is bigger than those two, D is the optimal solution. If this slope is in between these two, point C is the optimal solution. If this slope is smaller than these two, then point B is the optimal solution. And so to find that profit, we plug point B into the profit function. The profit function is 60 times 0 plus 40 times 90. And the maximum profit's at 3,600. So our optimal solution is 0 and 40. So this person's going to grow 0 acres of crop A, 40 acres of crop B, and profits will be maximized at 3,600.